Hello from the lab. In the next video series, we will distill palinka. We will go through a complete distillation process step by step with each machine of our in-house product line. All three machines have the same water-jacketed, double-walled kettle with a gross capacity of 100 liters. The machines are available with different heating options such as gas, electric, or wood. To ensure a proper copper surface, our column still models have a catalysator and copper rings. Here, from the test room, we will show you distillation technology videos, but a separate technical description of the machines will be available as well. And we will also share details about the design and manufacturing technology. In the distillation technology videos, our machines are fully equipped. For more information, please visit our website. The next distillation performed on our Trias universal machine will be the first round of a pot still distillation, namely distilling the mash. We have already installed the machine, assembled it. The clamping knobs are tightened. The machine is completely ready. The water supply taps have been opened. The system is under pressure. In addition, we also need to fill the end cooler by opening the rotameter. If we perform a pot still distillation on this universal machine, the steam will not pass through the column. Instead, it will go from the cupola directly to the end cooler. Let's look at the path of the steam through the piping system. Once the mash in the kettle has reached the boiling point, the steam will rise up through the cupola. It arrives at this pipe section, continues upwards, and then goes into the end cooler. We can achieve this by closing this tap and by setting the three-way tap in this direction. Since the tap is closed, the steam cannot go in this direction. It is forced to move in this direction. Since the steam cannot go in this direction, the column will not take part in the distillation. The three-way tap lets the steam go through this L shape. The operating principle of the three-way tap is as follows. This is a so-called T-tap. You can see the holes here. In this position, if we look at it from a little further away, it gives way in this or in that direction. This upper part is plugged, so even though there is a hole in the upper part of the ball valve, the steam cannot exit because it is plugged there. The steam coming from the bottom part enters the T and can only move to the right because the left side of the ball is closed and has no hole. If we turn the tap, we can see that the closed end of the ball appears on this route, so the steam cannot move upwards from here. The steam can only pass through the tap from the top of the rectifying column and move towards the end cooler, since the upward route is also closed. This is the position of the pot still distillation, and this is the position of the column still distillation, with the rectifying column. Let's start loading the ingredients. A loading funnel is available for Trias if you want to fill in the kettle manually, but filling through a pump is also an option. Fill in the 80 liters of mash. Add a level tablespoon of anti-foaming silicone oil to the mash. Put the door back in its place and the distillation can begin. During pot still distillation technology, The goal is to extract all the alcohol in the mash and the volatile substances that distill with it. We do not need to use the Pistorius plate for this purpose, only if the alcohol content of the ingredient is very low. This deflegmator can be used when we distill a mash with an alcohol content of 2 to 3%, in order for the low wines, which is the final product of the first round distillation, to have an alcohol content of at least 20%. Turn on the electric heating power through the electric switch box. Main switch, 6 kilowatt, 4 kilowatt, 2 kilowatt, potentiometer set to maximum. And let's start the mixing motor. Let's turn on the digital thermometers. Since we will not use the column, we do not need to turn on the deflegmator thermometer. We set the sound signal of the mash thermometer to 90 degrees Celsius. We set the sound signal of the thermometer on the cupola to 85 degrees Celsius. During the classic distillation of the mash, the aroma baskets are typically not used, unless there is a unique recipe. During the distillation of the mash, when the distillate begins to flow, we immediately collect the flowing low wines in a collecting jar. We can place the alcohol meter in the distilling parrot even before the distillation begins. For the sake of the test, we will collect the low wines in liter fractions. We measure the alcohol content and the length of time of the flow. But typically it is enough to collect the low wines in a larger container of approximately 20-25 liters. It is important that during the first distillation round, which is the distillation of the mash, we do not need to separate any heads. The goal is to extract all the alcohol from the mash, or a significant portion of it, along with all the volatile components, including both good and bad. The cupola thermometer started to rise intensely. We can see that we are close to the boiling point. The sound signal alarmed us at 85 degrees Celsius. We usually like to perform the distillation of the mash as quickly as possible, so we use the highest heating power. However, we must be careful with the mash. It should not run up during the sudden foaming. This depends on the ingredients as well. To avoid this, we reduce the heating power. We can start the distillation at around 6 to 8 kilowatt. Later, when the mash collapses due to boiling, we can increase the heating power again to 10, even 12 kilowatt. We'll talk about it later, but keep in mind that it will require significantly higher cooling capacity, so we need to provide a water flow of up to 150 to 160 liters per hour to the cooler, to keep the temperature of the water leaving the cooler below 60 degrees Celsius. At this moment, the distillation has begun. The starting alcohol content is close to 60% alcohol by volume, which is perfect. We can start with a high flow rate here, and from here all we have to do is collect the flowing low wines. Once distillation begins, set the amount of water flowing through the rotometer to 80 to 100 liters. This will go into the end cooler and cool it down. We started the distillation at 6 kilowatt, and soon we will turn on 10 and even try at 12 kilowatt. We collected the first liter, which has an average alcohol content of 57 to 58% by volume. From the second liter, we switched to a heating capacity of 12 kilowatt. You don't necessarily need to rush this much, we are just doing it for the test. We have to constantly check and monitor the machine to make sure the raw material is not foaming. We are monitoring this, but at the moment the distillation is going smoothly. The alcohol content of the second liter is 48%. Of course, the measuring can also be done with a classic alcohol meter. The distillation of the mash, or the low wines itself, is a perfect opportunity to get acquainted with the characteristics of the tails. We can taste it without any problem between 30 and 50% alcohol. Of course, you can taste it at lower alcohol levels as well, but then you need to count the disturbing effects of alcohol. This is clearly not good. The third liter is 44%. It is important to ensure that the temperature of the flowing distillate is below 30 degrees Celsius. At the moment, our distillate is flowing out at a very high volume flow rate, and this requires over 160 liters of cooling water per hour for the end cooler to function properly, and to ensure that the temperature of the flowing distillate is below 30 degrees Celsius. The cooler is working properly when the bottom 2/3 are cold to touch and only the top is warm. The fourth liter has 42% alcohol. As we got used to it during distillation, as the alcohol is removed from the mash temperature is continuously rising. We have already collected 12 liters from the first distillation round and have exceeded 99 degrees Celsius. We are getting close to the end of the distillation of the mash. The mash temperature has already reached 100 degrees Celsius. We collected more than 15 liters. The current alcohol content is already around 10 to 15%, and we will soon be able to stop the distillation. Towards the end of the distillation of the mash, the tail character is extremely strong. This is when you can practice and memorize this undesirable smell. After collecting 17 to 18 liters of alcohol, we can finish the distillation of the mash. The current alcohol content has already dropped below 10% by volume. We have collected both useful and useless components, which will be followed by refinement, the second distillation round. The mixing motor can still operate during emptying. We have 18 liters of low wines after the first distillation round. You can see that the low wines is opalescent, which is completely normal due to the low alcohol content. The alcohol content is 26%. It could happen that it is significantly higher than this, in case the raw material has a high alcohol content, such as grapes or plums. In that case, we would have to dilute it back to this 20 to 25% volume with normal tap water. We usually perform the refinement up to 30% alcohol content without dilution. The distilling parrot works in the following way. The distillate flowing out of the end cooler flows through this pipe. We have a breather here so that it can get a constant supply of air, and our distillate can flow out evenly. Then the measuring section of the distilling parrot is filled. The alcohol meter is located in the measuring section of the parrot. The parrot must be placed horizontally so that the alcohol meter will be located in the center. After the distillate has overflowed the measuring tube, it can be seen from above that it flows into a thinner 12-gauge tube and arrives at our collecting jar through the outlet tube. Another name for the distilling parrot is continuous measurer, since at every moment, the alcohol meter shows the alcohol content of the distillate that is currently flowing through the distilling parrot. Under normal circumstances, we do not need to collect the distillate by liters. It is enough to use the collection container, and we can monitor the decrease of alcohol content during the distillation of the mash on the alcoholmeter in the distilling parrot. As we have already discussed, the maximum filling capacity of the kettle is 80 to 85 liters, and we recommend a minimum filling volume of 35-40 liters. After one distillation round, we produced 18 liters of low wines, so this is less than the recommended minimum filling volume. For the sake of the test, we will continue with this now, but we recommend pouring the product of at least 2 mash distillations, i.e. 30-40 liters of low wines, into the kettle during refinement. If too little solution is poured into the kettle, The inner kettle cannot deliver the heating power due to the double-walled jacket, and the safety valve may blow. In this case, we need to reduce the heating power. So, fill in the low wines. It is even better to use a safer distillate container. During the second round of distillation, or refining, we will use our Pistorius plate, a water-cooled deflegmator, so fill it with water. We fill the Pistorius plate until the overflow, and the heated water will exit through the overflow and the outlet way. Let's start the distillation. We start the heating phase with a heating capacity of 12 kilowatt. The mixing motor can be used optionally. It is not absolutely mandatory, especially with such a small volume that we have filled in now. The mixing blade barely reaches it. If we have a little more low wines, we can turn it on without any problem. For the sake of testing, the mixing motor will operate now. Since the alcohol content of the low wines is higher than that of the mash, we expect a significantly lower boiling point. For this reason, we set the sound signal to 60 degrees Celsius. Due to the small filling volume, the high heating power of 12 kilowatt will quickly heat up the low wines to boiling point. Let's pay attention to the start of the distillate. We also set the sound signal of the cupola thermometer to 60 degrees Celsius. All the clamping knobs are checked before each distillation begins. We secure the connections. If they are not properly tightened, we tighten them. We also prepared for collecting the heads. We are currently performing a classic refinement, where we use the water-cooled Pistorius plate. The direction of the steam is as follows. As it exits the cupola, it continues horizontally. Then it goes through the vertical pipe, because this tap is closed, so the rectifying column is excluded now. After the vertical direction, the steam turns to the right towards the end cooler, condenses in the end cooler, flows down, and in the meantime cools down. The three-way tap is set in a way so that this direction prevails regarding the direction of the steam, so steam cannot flow into the column from the upper section either. If we use a water-cooled deflegmator during the refinement, we can be sure that we will produce highly concentrated hearts, and the cutting border of the head's heart's tails will be sharp. We can also be sure that we will have clean hearts, free from tails contamination, so we will get a useful distillate after the distillation. The mash thermometer has warned us to pay attention to the machine. The aroma tower is not yet hot. The water in the Pistorius plate must be heated by the steam rising upwards. Then it can break through this water-cooled deflegmator. We will now pay attention to this. We will soon take back on the heating power, because we are now using a disproportionately high heating power of 12 kilowatt for only 18 liters of raw material. When the mash thermometer, or currently our low wines thermometer, reaches 60 degrees Celsius, we switch back to 4 kilowatt of heating power. Then, when the line arm starts to heat up as well and the cupola thermometer warns us, it is enough to use only 2 kilowatt of heating power. This is currently recommended, since we have only approximately 20 liters of low wines. But if we have a larger amount of low wines, we can start the heads at 4 kilowatt. The cupola thermometer is warning us. We are turning back the heating power. There is little raw material, so 2 kilowatt will be enough for the slow beginning of the heads. We start the collection of the heads with a slow process. The distillate has to flow slowly. When the heads start, we start cooling the Pistorius plate. An initial cooling volume flow of 20-40 liters per hour is enough. The cooling of the cupola is regulated so that there is a temperature difference of approximately 3 to 4 degrees Celsius between the mash temperature and the temperature of the steam exiting into the line arm after cooling. The mash temperature is always higher. At this moment it is 85 degrees Celsius, and the temperature of the steam heading towards the line arm is 80-81 degrees Celsius. The classification of the heads, namely the cutting border of the heads and the hearts, is carried out with the previously known method. In our case, the third fraction was already considered hearts. Let's move on to collecting the hearts. The alcohol content of the first fractions of the hearts is already high, so try not to separate more than necessary, because useful aroma components already gather near the cutting border of the heads and the hearts that are worth keeping. We are currently collecting the first liter of the hearts. The steam temperature exiting the Pistorius plate is 83 degrees Celsius. The temperature of the low wines, so the mash thermometer, is currently showing 86 degrees Celsius, so we can maintain a temperature difference of about 3 degrees Celsius. In order to do this, we add 30-40 liters of 18 degrees Celsius water per hour to the deflegmator. The first liter of the hearts has flowed out, with an alcohol content of 82% by volume. The flow rate of the first liter was 13 minutes. With intensive cooling, which in our case is currently 50-60 liters per hour, we can create a temperature difference of 4 degrees Celsius between the steam temperature exiting the cupola and the boiling point temperature of the mash. At the moment we are collecting the second liter. The greater the temperature difference is, the slower the flow rate of the distillate will be. The heating performance is currently 4 kilowatt. Meanwhile, the second liter of the hearts has also flowed out, with an alcohol content of 80% by volume. At the end of the second liter, we switch to 5 kilowatt heating power. At the moment, the water temperature of the Pistorius plate is approximately 50-60 degrees Celsius. We can continuously monitor the quality of the distillate flowing out. We will experience that the aroma content of each fraction is constantly changing. This way we can get to know the nature of the given type of distillate. At 91 degrees Celsius mash temperature, which is currently the temperature of the low wines, 50 liters of 18 degrees Celsius water per hour is needed to ensure that the temperature of the steam exiting the Pistorius plate is 88 degrees Celsius. So we can see that we can maintain a temperature difference of 3 degrees Celsius using proper cooling, which is enough for us. The temperature of the low wines is already 93 degrees Celsius. Above 90 degrees, we already pay attention to the possible presence of the tails. While we are less experienced in the field of distillation, from around 92-93 degrees Celsius, we recommend collecting the distillate in separate fractions of half-liter or liter, so that we can classify them independently to determine whether it already contains tails or not. While the distillate is flowing out, we can check smaller fractions from time to time using the well-known skin test, which helps us determine whether the distillate contains tails. In our case, we can already experience that, so we will stop the distillation. In our case, the boiling point temperature of the low wines at the end of the refinement was 93.7 degrees Celsius. This is what the mash thermometer showed, and the distillate still had 70% alcohol content. Here, the tails already appeared in the fraction. Turn off the electric switch box. Turn off the main switch and turn the potentiometer back to 0. After the distillation, the water in the Pistorius plate can be drained. It exits through the outlet pipe. We remove the distilling parrot and rinse the end cooler. The low wines waste can also be drained into the sewer. After the distillation, once the different parts of the machine have cooled down, we can take the system apart. We can remove the cupola and the Pistorius plate and properly rinse it, so we can start the next distillation with a clean machine. The result of the pot still distillation is 4.5 liters of hearts, with an alcohol content of 77%.